Hello all. So today we are going to discuss more problems regarding the module 2. So coming to the problem, a smooth backed vertical wall is 6.3 meter high and retains a soil with a bulk unit weight of 18 kilonewton per meter cube and phi is equal to 18 degree. The top of the soil is level with the top of the wall and is horizontal. If the soil surface carries a uniformly distributed load of 4.5 kilonewton per meter square, determine the total active thrust on the wall per linear meter of the wall and its point of application. So this is the case in order to find this earth pressure, that is active earth pressure, when the wall or the soil backfill is carrying a surcharge, which is having a value of 4.5 kilonewton per meter square. So you have to find the total active force acting on the retaining wall, including the force due to the earth fill as well as the surcharge. And the given values are: the unit weight is given as 18 kilonewton per meter cube and the angle of internal friction is given as 18 degree, which is used to calculate the active earth pressure coefficient, and the height of the retaining wall is given as 6.3 and the surcharge value is given as 4.5 kilonewton per meter square and it is denoted by Q. Now, when we draw the pressure distribution diagram for this case, that is, first of all, this Q is represented as the surcharge and due to which the pressure is denoted by Ka into Q, that is the active earth pressure coefficient multiplied with the value of the surcharge, and it is represented as in the rectangular form. And near to that we have to draw the pressure due to the backfill and the active pressure due to the backfill, which is given by the value Ka into gamma h, that is coefficient of active earth pressure multiplied with the overburden pressure of the soil, which is given by gamma into h, where gamma is the unit weight of the soil and h is the height of the retaining wall, and it is drawn in the shape of a triangle. So this will be the pressure distribution diagram for this case, that is when it is given a surcharge along with the backfill. And the values corresponding to each of these are, that is, first of all, the pressure due to surcharge is given by Ka into Q, which is given by 23.8 kilonewton per meter square, and the earth pressure, active earth pressure due to this backfill, which is given by Ka into gamma h, and by substituting these values we will be getting 59.9 kilonewton meter square, that is where Ka, that is coefficient of active earth pressure, is calculated with the help of the formula, that is 1 minus sine phi divided by 1 plus sine phi, where phi is the angle of internal friction whose value here it is given as 18 degree. So we will be getting the value of the active earth pressure coefficient as 0.528, and substituting the corresponding values we are getting the corresponding pressures, and the total active thrust or force will be obtained by finding out the area of the pressure distribution diagram. And for this we have to sum up the areas of the rectangle as well as a triangle, and the area of the triangle is given by half BH and the base value is Ka gamma h, that is 59.9. So 1 by 2 into 59.9 into the height of this wall is 6.3. So 1 by 2 into 59.9 is 6.3 plus then the area of the rectangle, which is L into B, that is K into Q, whose value is 23.8 multiplied with the height, which is 6.3. So 23.8 into 6.3, and when we add these two we will be getting the total active force acting on the retaining wall, and which is given by 338.6 kilonewton. And in order to find the point of application of this force, for that we have to find the moment, and for each of these force, for corresponding to this each of these pressures, that is for pressure 149.9, the point where it will be acting will be at The h by 2 distance, as the shape of this pressure distribution diagram is rectangle. So 6.3 by 2 will be the point of application for the pressure 149.9, and the pressure whose value is 188.7, which is due to this oil earth pressure, and that force will be acting at a distance of h by 3 distance, that is 6.3 by 3, and hence the location will be 6.3 by 3, and when we divide with the total force we will get the point of application of the total resultant force of 338.6, and that is 2.56 meter. In this way we can get the point of application of total force. Now coming to another problem, that is a vertical wall with a smooth face is 7.2 meter high and retains soil with a uniform surcharge angle of 9 degree. If the angle of internal friction of soil is 27 degree, compute the active earth pressure and passive earth resistance assuming the unit weight as 20 kilonewton per meter cube. So here it is given that it is inclined backfill. So this is the figure, that is, this will be the form. So in this question you have to calculate both the passive as well as the active force acting on it, and it is the inclined backfill. And for that the inclination angle is given, the unit weight is given, the height of this retaining wall is given. You have to find out the active earth pressure coefficient as well as passive earth pressure coefficient, and with the help of that you have to calculate the active and passive pressure. So this will be the diagram for the corresponding question, that is inclination is given as 9 degree and inclined backfill and inclined surcharge, and the height is given as 1.2, and using the equation to calculate the active and the passive earth pressure coefficient if the backfill is inclined, and this will be the equation for that. And you just have to substitute the angle of inclination which is given as 9 degree in order to calculate these coefficients, and henceforth we will be getting the values for active earth pressure coefficient as 0.392, that is just substituting the angle of inclination as 9 degree, and phi is the angle of internal friction which is given as 27 degree, and substituting these in this equation for coefficient of active pressure as well as the coefficient of passive pressure, we will be getting the values as 0.392 and 2.488 respectively. And then you have to substitute in the equations in order to calculate the passive pressure as well as the active pressure, which is given and as K into gamma H. And if you have to calculate the force, then you have to calculate the area of the corresponding diagrams, and which will be given by half gamma H square into Ka in case of active force, and half gamma H square into Kp in case of the passive force. So substituting that in the corresponding equations, we have got all the values for these, that is Ka is obtained, Kp is obtained, and gamma is given, H is also given in the question itself. So from this we will be getting the active force as well as the passive force by finding out the corresponding active earth pressure coefficient as well as passive earth pressure coefficient. We will be getting the respective forces.